Why C++? A question I often ask myself. Why C++? Why? To start off, I think it's worth stating that I don't subscribe to language jingoism, or the idea that one language is somehow inherently better or worse than another. There isn't a total ordering of languages such that one is demonstrably superior. For me, languages are tools, and the ultimate aim of engineers should be to use the right tool for the right job. So in 2022, when would you reach for C++? Well, we can start off by looking at some of the pros. Multi-paradigm. C++ doesn't enforce any particular paradigm or way of working onto the programmer, which provides maximum flexibility to tackle a problem in whatever way makes sense given the domain, data, and restrictions. It's possible to use procedural programming, object-oriented programming, functional programming, and more. Statically typed. Whilst you could argue on the internet all day about the precise meaning of statically typed, the gist is that the type of a variable, int, string, float, is known at compile time and, once declared, cannot change. The advantage of this is that the compiler can perform a lot of validation for you, such as checking operations you perform on a variable are valid for that type. This can catch a whole host of bugs before the program even runs. Cross-platform. With C++ being 37 years old, there exists a compiler for pretty much every platform. I don't think there exists a definitive list of all platforms which have a C++ compiler, but just looking at the supported architectures of GCC, we can see ARM, x86, MIPS Titanium, PowerPC, Spark, and the ever-relevant PDP-11. And that's just one compiler. I should add that your program would need to be compiled for each platform that you'd want to run it on though. High level. The C++ standard library provides many high-level abstractions which allow you to quickly and efficiently solve problems. For example, dynamically resizable arrays, hash tables, random number generators, string formatting, and more. Low level. Conversely, C++ is also low level. It provides the capability to do manual memory management, low-level atomics, and even drop directly down to assembly. The thing with C++ is that it provides a wide spectrum of control and all the dials and levers you need to achieve your goals. Efficient. I'm hesitant to say C++ is fast, as it's certainly possible to write slow code, but as C++ is typically compiled to native assembly, this provides the opportunity for very fast execution. The language and library also try to follow the zero-cost abstraction principle, which means you only pay for what you use, and what you do use, you couldn't handwrite any faster. So, by understanding and following good C++ idioms, you stand a chance of getting performant code. Now hopefully this has warmed you up to C++ as a language, but before you quit your job and disappear into the mountains to learn it, I should mention some of the cons. Complex. The language is complex. It's been refined and worked on for nearly 40 years. The specification, i.e. the document which details exactly what the language and library do, is over 1800 pages long. And, because of its wide spectrum of abstraction, it goes pretty deep into things like coroutines, atomics, and templates. Errors. What follows with complexity is the potential for egregious error messages when something goes wrong. For example, trying to assign a custom type without a conversion function to an integer? Reasonable error. Trying to print a custom type without defining how to do it? 20 kilobytes of errors. Choices. Whilst I mentioned earlier that C++ doesn't enforce any particular paradigm or way of coding for flexibility, this makes it difficult to describe what good or idiomatic C++ actually looks like. Not only is it highly subjective, but it changes based on the problem domain as well as the C++ version being used. And as C++ tries very hard not to break backwards compatibility, we end up in a situation where there are now 14 different ways to instantiate an integer. I've just covered some of the pros and cons of the language, but what problems do require a tool like C++? Any project which requires low-level hardware control, deterministic resource management, or fast execution are good candidates for a C++ solution. Is it the only solution? Probably not. A prime example of this is for games engines which need to be fast, efficient, and control low-level graphics APIs. And this is why I chose it for my custom game engine Iris, which is open source and linked in the description. To see how I leverage C++ to write a custom profile of my engine, check out this next video.